So, this is a cone problem from the related rates chapter in Calculus 1. Now, this is a later chapter. It may be complicated at first, but take your time to read this question and I'll show you how easy you can understand this and do similar problems in the future. Alright, so the first thing I would like to do with this question is identify all the constraints and important details in this question. So, I would say that the radius and the height are very important, as well as the rate itself. So, look for any numbers or any critical details such as radius, rate, or height, or etc. in the question, and those will give you the important details. Next, we are going to draw a picture that will show us this inverted cone and all the details that we took out from the question picturized into one element so we understand what is going on exactly. So here I'm writing my height and radius, as well as the important detail when our water is about 2 feet deep. That is another height that we have to deal with, but that's till later. Now, we also have to talk about what the rising and sinking means. And in other words, that's the rate of change of our volume, which means we're going to use derivatives. Now notice that I used dV over dt even though I said rate of change of volume, but actually it is the rate of change of volume with respect to time because it clearly says feet cubed per minute. Now this is a cone, so when we're talking about volume, we must remember the volume of a cone, which is 1/3 pi r squared times h. But we have a problem here. We're trying to take the derivative of volume, but we have an r and an h, and if we take the derivative of this equation, we're going to take the derivative of both r and h with respect to t, which is bad because we only need the derivative of h over dt. We don't need dr over dt, and we don't even know dr over dt. So we can't solve for dh over dt alone if we also get r into our equation. So what do we do then? Before we go any further, let's make our goal clear since we have written down all our constraints. Yes, we need to find dH over dt. Why? Because it's asking us how fast the water is rising when it's at 2 feet of depth. So, since it's talking about depth and it's talking about rising, it's talking about water level, which in other words is height. Now we have to come back to our problem. We have an r. We don't need r, right? It's going to make everything too complicated. How do we get rid of it? Well, it's much simpler than you think. In our drawing, we see that the radius and the height of the tank itself is actually proportional in some way, right? The radius is half of the height. So we can use that ratio to our advantage. So we wrote down our ratio, right? All we have to do now is to really substitute the r with the h. And then we only have one variable we need to deal with, and that's the correct variable we need to find dh over dt. Let's go. Let's try it out. I'm going to substitute my r with h. And it's going to be simple because r is only half of h. So we subbed r with h, which is good because now everything's simple and all we have to do is take the derivative and then sub in the values, and then we can isolate for dh over dt and find the answer. So all this is a power rule, nothing more. Oh no, so I forgot the dH over dt there, so make sure you have it too on your paper. If you don't, it's going to be a huge problem. So we already have our values from our question, and all we have to do is substitute in the values. We have dv over dt, which is 5, and h is given to us, which is 2. All we have to do is sub in the values and we get our answer for dH over dt, and it's very simple, like I said. Nothing to fear about. Alright, so this is it. This is dH over dt, but make sure to have the answer written in the proper format by putting in the units. That's good practice, even if your teacher doesn't mind. Just make sure you have everything like that, all your steps are clear, and your answer is good to go. Thank you for watching, and see you next time.